So, welcome to question 5 on the DEB Pre-Junior Cert Graphics Exam 2023. So the image on the right shows an intercom that can be mounted on the gate pillar. Okay, so that's from the previous question we were dealing with this gate here. The speaker is elliptical in shape, so an ellipse shape there. The given lengths of the major and major axis AC, that's our major axis, and minor axis BD are given below. Draw the ellipse. So you can use whatever method you find best, but concentric circles is the one that I always am drawn to using. So my major circle drawn using the major axis given. Okay, now I'm going to draw a minor axis, a minor circle. So using the minor axis as my radius or as my diameter. And now we want to split that up using our 60-30 degree set square. Okay, so where these 60-30 degree lines cut the major circle, we draw towards the major axis. So major, 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 major. Okay, so let's draw those. There, that's the minor axis we want to draw out towards there. So this line puts the minor here, so draw towards that. Same on the opposite side. Okay, so that finds its points all the way around. B will be a point on the minor axis. And our freehand curve then, always looking at the point we're travelling to. Try and draw it as neat as you can. Have a look at the point of the pencil, always look at the point you're travelling to. It just gives us a nice, more gentle curve. Okay, so that's our ellipse drawn. Now locate the focal points. Focal points, we get them by getting half of the major axis. That's half my major axis. Okay, and I can swing it from either side of my minor axis. So, swing an arc there. So that's half my major. Swung from B or swung from D. We'll find the same point. So swung from B. So that's focal point 1, focal point 2. And all my constructions clearly shown there. Right, on to part B there. The buzzer button, so here's our little buzzer button down there, and it's shown across. It is based on a parabola BEC, so B to E to C, with vertex E. So our vertex, our turning point, is going to be here. Redraw the parabola in a given rectangle ABCD. So here's our rectangle. So we want to show our constructions clearly. So what we want to do is we're going to divide up AC into equal parts, and we're going to divide up AB to equal parts. Let me just see, can we measure those? No, not quite. Okay, so we're going to have to use our dividing lines into equal parts construction. So line at any angle, draw a line out, and actually draw one here as well. Line at any angle. Okay, so for AB, let's divide this up into 3 equal parts, will be fine. So 1, 2, 3. Might even go forward. 4th. Yeah. Just measure it. No, okay, that's not a visible line either. Okay, so slide and set squares then. Important line is from B to that line we found. Swing an arc, or draw parallel lines. Okay, now this line here, that's parallel to our vertex. We're going to join each one of those, 1, 2, 3, back up to our vertex. They have to join to our vertex. Okay, a very common mistake is for people to draw those lines down the page. Okay, now we want to divide up this side into equal parts, so let's go 1, 2, 3, 4. Extend that line on a little bit. I'm going to join the ends back to A. Yours might look slightly different if you've got a different angle or a different distance, okay, but what's important is we're doing the method correctly and dividing a line into equal parts, and we get this here. So the side that contains the vertex is going to go parallel to the axis line. So dropping a line down, down, and down. Okay, so this is point 1, point 2, point 3. So 1 and 1 match up, 2 and 2, 3 and 3. And we can freehand curve that, looking at the point we're traveling to, back like that. That's half of our ellipse, or our parabola. Now we need to find the second half, and we're going to do it by axial symmetry. Okay, so a mirror image. So I've done this earlier in this paper. So we're projecting through the axis at 90 degrees at 3 points, and the distance from here will be the same down here. So point of the compass on my axis. Okay, swing an arc there. So that finds me point 1. Point of the compass on my axis again. Swing an arc. Okay. Now I know I've seen in past people putting their point of the compass on the vertex, right, setting it to that distance and swinging it across. You will find it the correct answer, but it's not the correct method. Okay, so we want to put our compass on our axis and swing it across. So that you can see that arc is drawn in the correct position. So point, 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 and we'll draw our freehand curve. Back like so. So that is part B complete, our parabola. Then the image on the right shows a handle bolt which is often fitted in a gate. Oh yes, so for sticking into the ground. Complete the drawing of the top of the handle by constructing a tangent from point P to circle M. So from point P to circle M, we're going to end up getting a tangent like that. Okay, the construction for this is we join P to the center of the circle. I'm then going to bisect that line in half. Swing an arc, set it to more than halfway, swing an arc, keep that same distance on the compass, swing an arc, and now I join where the arcs cross each other. Okay, now we are going to draw a semicircle. Okay, with radius half of that distance. Where that semicircle crosses my circle, that is called the POC, the point of contact between the tangent. So that's my tangent and the circle. So here's my tangent. Okay, so that is question 5 on the DEB paper 2023 completed. Nice two conics questions and a tangent to a circle question.